We're doing mechanics now. Gotta be doing chalk now. Right, so what we're gonna do... Alright then, we're starting a new topic and it is vectors. Vectors is the precursor to mechanics. So I'm gonna bunch this all into a new segment of we're doing mechanics now. In the sense of my videos, I've actually not done a video for a while on my channel. But we're jumping back in. I'll still do the pure bit, but we're now doing mechanics along the side of it. For the sake of what's happening in the world at the moment. Isn't that good? So to do this, we're going to start with vectors, and in this video I'm going to be saying what actually is a vector, how do you write a vector, and what is a unit vector. So let's get started and we'll look at some examples about what one is. Right, so I've written the title of this as vectors, direction and magnitude, because that is what a vector is. Some things don't need a direction, like my mass is 65 kilograms. That doesn't have any importance of direction. I'm 65 kilograms here, I'm 65 kilograms over here, I'm 65 kilograms here. However, some things actually need a direction. Like if I was to say I'm going to walk 5 meters, you'd be like, all right, well, in what direction? Straight up, straight down, over there, or in a mixture between all of those three. And that's what a vector is. It's something which has a direction and some quantity, some size. We call that size the magnitude. So vectors have direction and a magnitude. But what does one look like? Well, imagine I was going to walk 5 meters and you're looking down, like you're a seagull looking above, from above, and you see me walk 5 meters. You might see me go something like this. Start there, end there. What I've actually done though, if we compare it to some kind of grid reference, so we put it into a grid, a little bit like a map or just some Cartesian coordinate system. That's the horizontal, that's the vertical. What I've actually done is I'm going to use a different colour for this, red. I don't know why, but actually writing in chalk, it's better if you snap it first. So I've gone across by 3 and up by 4. This is the X part because we put it on a coordinate system, and this is the Y part. And what I'm going to say is that this vector, we'll call it A. Usually, if you see it written down, A will be in bold, but because we're doing handwriting, you can't do bold, so you do a little line under it. I mean, on a chalkboard, I could maybe like be like that, but you don't really do that, or let's get rid of that. Okay, so this is what my vector A is like. I've gone along 3 and then that way 4. It's a top-down view, so that's what it is. Imagine then that someone else is walking a different way. They actually start maybe here and then they end up there. In the same kind of XY coordinate system, they've gone -4 and then 2 in the X direction. -4 and then 2. Let's call this a different vector. Let's call it B. There we go. So these are 2 vectors. Great. But now we need to know how to write them. And there's 2 systems for writing vectors. One is called IJ format and one is called column vectors. Now, just in point, this is a 2D thing. This is imagining me just walking on the flat. In our real world, we're actually 3D, and you would extend it to 3 dimensions. You'd be like that. That's simple enough. Purple. Let me get this written properly. Right, I've written this down. Now, this chalk is such bad quality. I don't know if you can read it. Anyway, so here are our 2 ways of writing it. We've got column format where we do X and Y. This is what we've done in X, so this is what we've done Y. We put it as a little column vector. So this one, 4 and 3, what we'll write that as is, we've gone along in the X3. Oh, no line. And Y is 4. We'll do it like that. This is A. Very good. B. Right, that's it. Now we've got IJ format, where these I and this J, what these are like unit vectors, base vectors. I'll come back to a unit vector in a moment. The base vectors, which say like 1I is just going in the x direction by 1. 1j is going in the y direction by 1. I'll make a note of that. So what we can do is write this 3i plus 4j, and then b 2i minus 4j. So you've got your minus 4, which is your y component, your j and your I are underlined because they're base vectors. Now, I said base vectors, I'm just going to define this quickly. I is 1, 0 and j is 0, 1. That's it. That is it. So this is how we actually write vectors. But now we can write them, we're going to move on and say, well, what is actually magnitude and direction? So magnitude is the first one that we'll talk about because it's kind of simple. It's Pythagoras. Okay? Remember here I said I'd gone a distance of 5 meters. Well, that's the length of if I actually measured start to end. So let's do that. Right. This is definition of magnitude. Magnitude is the length of a vector. So if we had a vector v, we'd write the magnitude as it's a v, which is our vector, with vertical lines next to it. That means magnitude. What that's going to be is x squared plus y squared all square rooted. It's just Pythagoras on here. It's just Pythagoras. That's all it is. But what that means is that magnitude is always positive. Implies it's positive. So let's have a look at our examples. A, magnitude of A, is 5. That's all it is. Now let's have a look at B. Now B, when x was 2, y is minus 4. But because this minus 4 is squared, then that becomes 16, that is 4, so it's root 20. Can you simplify root 20? 4 and 5, 2 root 5. Need your surds for this. So that's the magnitude of something. Now let's talk about what the direction is. Right. Direction is the angle made with another vector. You see, we always have to refer to what we're actually measuring this direction to. You see, like, is it 30 degrees to this line? Is it 30 degrees to that line? Which one is it? So you have to specify which you're doing it to. Here we could say our angle is compared to the horizontal, or you could say it's compared to the I direction. You get that? Let's do a little example. All right. E.g., the direction of A to I. Direction that A is making to I. All this is we want to know what that angle is. So it's a little triangle, therefore we're going to use trigonometry. It's a right angled triangle, so we're going to use 𝗃. We've got the adjacent, we've got the opposite, so we're going to use tan. So tan theta is opposite over adjacent. Opposite is 4, adjacent is 3. Inverse tan. If I do this in my head, I think it's about 36.9. 36.9 degrees. That's the direction of A compared to I. The direction vector of I. I would have done that on my calculator, but it's still missing. Great. Down this side of the board, God, it's such a big board now. We're going to do a few examples. So, let me get an example. We've got another vector. What is the magnitude of this vector? This is a good one. So magnitude, we're just going to use Pythagoras. So we're going to do square that one, square that one. So what have I got this in my hand for? Hope you followed that algebra. It's fairly straightforward. The magnitude of C is 1. Now this is a good example because this is a unit vector. The definition of a unit vector is that the magnitude of it is 1. So it's just a normal type of vector, but it's one where its magnitude is 1. So that's it. Does that mean it's possible to make a unit vector out of what we've got? So if we wanted the unit vector of A, we want the magnitude of it to be 1. So if its length there before was 5, what if we just divided that by 5? Which meant that we would divide all of its terms by 5. So if we times, let's get this down. Just thinking of this one off the top of my head, that's why it's not going very well. So if we had a new vector, A equals that. Now notice it's the same one as before, but we've divided each component, that's what each of these are called, components of A, by the magnitude. So now if we do the magnitude of A, this is what happens. That makes it into a unit vector. Now I'll come back to this in the next video where I'm actually talking about the algebra of vectors. Now we've got 2 more examples. One's a bit wordy, so let me write that down. Right, this is a tricksy one, very tricksy. Let's just V has a direction of 60 degrees to I, and the magnitude of V is 2√3. Write V as a column vector, that's the x, y column vector there. So what we've got is we've got our direction, we've got the magnitude, but we need to find what the components of the vector are. So what we're going to do is we're going to do it as a little triangle, like this. So this is what we've got. We've got our vector going up there. It's got a direction, so it's going up. It's making 60 degrees angle to the I, which is that way. So what we need to do is we need to work out x. So x is just going to be quite simply, it's using trigonometry. 𝗂𝗇, it's going to be 2√3 cos 60. Which, because cos of 60 is a half, this is just going to be √3. Yeah. Y is now 2√3 sine 60. And sine of 60 is √3/2. It's √3/2. So that means we've got 2√3 times by √3/2. 2's cancel, and you get √3 times √3. So 3. So that means, is this still on the board? Only just, we can squeeze it in on the right. There we go, and that's the answer to that one. Right, didn't use the board very well. But that is essentially it. What we've done in this video is how to write vectors in column and IJ format. Magnitude, we've done the direction, and we've done some examples. That's the definition of a unit vector, and this is how to go back to writing something as a vector once you've got magnitude and direction. Yeah, I managed to squeeze it all in. So next time we're looking at basic vector algebra, and then how to actually find displacement vectors and position vectors, and that's it, right? Sweet. There's one more thing which I didn't mention, just remembered it. Bearings. Bearings are a certain type of direction, but they're always measured from north. So when we measure like this has a direction of 60 degrees to I, that means you're folding it like out that way. A bearing is a certain angle to north, and it's always going clockwise. That's just a little sneaky bit on the end. Right, next time we're going to be looking at position vectors.